All right, for your warm-up, you use your calculator to match the graphs to go with each of the quadratic equations. And then I wanted you to also state any solutions if there were any. Okay, so let's start with our graphs. What did we match up with function number 1? What you got?
E.
Yes, that is graph E. We'll talk about solutions in a minute. What did you match up with function number 2? D. All right, how about what went with 3? That is C. There we go. 4. A. 5. And 6. B. All right, good. Does anyone remember what the solutions are of a graph? What you got, Brennan? The zeros. So they're called zeros. They're called solutions. What else are they called? X-intercepts. Nice. Okay, so what are the x-intercepts or the solutions for graph 1?
0.
We have 0. What else do we have?
2.
We also have 2. So our solutions for our first function are x equals 0 and 2. All right, what were the solutions for our second function? Just an x value of 1. There was only one spot. All right, how about our third function, graph C? Nothing. Yeah, we don't have any real solutions because it doesn't touch the x-axis. All right, how about graph 4, which is graph A? 0 and 2 again. All right. Function 5. 1 again. And function 6. It's none. Good. Hold on. It froze. There we go. All right. All right, so to summarize, how did you use the graph to determine the number of real solutions of a quadratic equation? What did you look at? You looked for the x-intercepts. Good. Does that determine up or down? No, graph E and graph A had the same solutions, right? They both crossed over at 0 and 2, but graph E is opening up, graph A is opening down. Okay, that's okay. Okay, so it looks like we have a combination of having one solution, right, where my vertex is sitting on the x-axis. D, it's going up, and then F, it opened down. We can have two solutions where it crosses over twice. That happened in A and E, or it could not touch at all, which is what happens in B and C. Okay, so if I ever ask you for solutions of a quadratic, which is what we're doing today and tomorrow, you should say no, there aren't any, or there's just one, or there's two of them, and this is what they are. Okay, today and tomorrow is a big Algebra 1 review. Okay, we are going to remember how to do solving quadratics. Okay, with real numbers, because the next week we're going to do it with imaginary numbers. Yay! I know, yay! Okay, but the process is going to be the same. Okay, the process will be the same. Using square roots will be the same, whether it's real or imaginary solutions. Okay, quadratic formula, factoring, all those good things. Okay, they're all going to be the same. Just next week, saying no real solution isn't going to be an option. All right. So today what we're going to focus on, we're focusing on graphs, and we're focusing on, I believe, using square roots. Yes, we're going to use square roots. Okay. And then when we come back next week, we'll work on the factoring stuff. Okay. So today and tomorrow, a quadratic equation in one variable is an equation that can be written in the standard form. Ooh, what standard form? Who remembers? There you go. Plus bx plus c equals 0. where A, B, and C are real numbers and A cannot equal 0. A root of an equation is a solution to the equation. So we've used the words solution, 0, root, x-intercept. Those are all talking about the exact same thing. Okay? Okay, root, x-intercept, 0, or solution. Those 4 words mean the exact same thing. Okay? So if I am looking at a graph, what are we going to look for in the graph? What did we just do in our warm-up? We are going to look for x-intercepts. Okay. Another way to solve is by using square roots. Okay. This strategy is used when in my standard form, the bx piece is missing. So you just have ax squared and a constant. Okay, because if bx is missing, you only have x squared that you have to work with, which eventually will take the square root of both sides. That's why it's called using square roots. Okay, we're going to remember how to do that today. And then tomorrow we will focus on factoring. All of these have the, no, I lied. Take that back. When it comes to factoring, completing the square, quadratic formula, those kinds of things, they all have the same fact in common, where you have to make sure your equation is equal to 0 before you do anything else. Okay, so if you have all 3 pieces of your standard form being present, it has to be equal to 0 before you can use one of our solving strategies. Yeah? Cool. Today's focus is graphing and using square roots. We're going to factor when A is 1 and when A is not 1 tomorrow. So I call them basic factoring and slip and slide. Sounds fun, right? It will be. Okay. Example 1, we're going to solve by graphing. So you did this with your warm-up. Okay. But now you have to actually plot points. So using our graphing calculator, this is kind of like the level 2, algebra 2 part of this, because in algebra 1, you were just given the graph and said, oh, what's the solution? Algebra 2, I'm going to make you draw that graph first. Okay, so we are going to graph x squared. So if we remember how to do it, we push y equals. We're going to graph x squared minus x, and then minus 6. We're already equal to 0. We're good to go. I have it in standard form. Okay. I don't put equals 0. You can't. Okay. This is going to graph the whole thing. So we're going to push our graph button. There it is. What do the solutions look like they are? It looks like 3 and negative 2. How can I make sure? We can do the trace. We can also go to our table, which is going to be really helpful because I need to plot multiple points, right? So let's get a list of points. So let's do second graph, get our table. Okay. Let's plot some stuff. So what is that? Negative 3, 6. I'm going to move this to the side. Is it going to work? There we go. That is so small. Okay, we got this. We have negative 3, 6. No, I can't do that. That's too tiny. I can't do it. Negative 3, positive 6. There we go. The next point on there, I believe it was negative 2, 0. Yes? Are y'all with me? Okay. Sorry, I thought I could do both at the same time. Negative 2, 0. Then we have negative 1, negative 4. Now I have 0, negative 6. 1, negative 6. 2, negative 4. 3, 0. And 4, 6. So I've plotted my points. Are any of these my vertex? No. They are not. It does a little dip in between these two. A little dip, and then it comes back up. But do I care about the vertex today? No. Aren't you happy? Woohoo. No, not for a while. Not for a while. Your graphing days are put on hold. Okay? So what are my solutions? X equals -2 and X equals 3. What's your question, ma'am? No, I pushed the up arrow. So I could see it. Yeah, I pushed up or down. Until I saw, the -6s together. So that showed symmetry. And then I see the -4s, the 0s, and the 6. Yeah, so I was looking for the symmetry. Because that's kind of the middle of my parabola. Or it is the middle of my parabola. Yeah? Beautiful. All right, part B. What's special about this guy? It is not equal to 0. So what do we have to do to make it equal to 0? Minus my 4x. And when I do that, where does it go? Is that my A, my B, or my C? It is your B. So it is -2x squared minus 4x minus 2 equals 0. So my B term was misplaced. We got to move it back over. It has to be equal to 0 first. And now I can put that into our calculator. I can expect this parabola to open which way? Down. So we need to make sure our math makes sense. All right, go back to y equals, clear this out. -2x squared minus 4x minus 2. Graph it. Look at that. It's opening down. What other special feature do I notice? Sure there is. There's one. Right? This time my vertex is sitting on my x-axis. Okay? To verify this, go to your table. See that symmetry, that reflection going on? I see -1, 0, and then on both sides, I start seeing our values repeat themselves. That shows the symmetry. So I'm going to graph what I can. Looks like -3, -8. Then there was -2, -2, -1, 0, 0, -2, and then 1, -8 is what I got from my table. And our solution is going to be what? X equals -1. Good, this guy right there. Okay, so this one was special because our vertex is on the x-axis. So that's why I only had one solution. 9 times out of 10, you're going to have 2 of them. This one is special. Not yet. It's coming up. They love you. Don't hate on the square roots. All right, lovelies, I want you to try these 2 on your own or with the partner you're sitting next to. I will tell you, number 1, it does go off the graph, and I'm sorry. You have a solution that goes this direction. Yeah, one of the solutions goes off the grid. Sorry. So you're not wrong, because sometimes I try to make sure your graphs don't do that to you so you don't question yourself. So I apologize. So you're graphing 1 and 2, and you are finding the solutions to those. Check your work with mine. What's wrong? Which one? The first one? Okay, okay. Let's see. All right, we have x squared minus 8x plus 12. All right. Oh, what did I do? What did I do? Never mind. It don't go off the grid. It's just fine. Just kidding. Okay. 2 and 5, right?
Yeah, I get to.
Okay. Just kidding, guys. All right. So I see symmetry happening down here. Looks like an x of net of. Okay. So 4, negative 4. All right. 4, negative 4. And then negative 3 on both sides. And then 2 and 6. 2, 5, 6. Just kidding. It's still off the grid. I just went the other way. I can't even connect my dots. Okay. Sorry, lovelies. How does the table also show x-intercepts, by the way? What on this, looking at this table, how can you look at just the table and tell me x-intercepts? When your y equals 0. Okay, when your y equals 0. So I have 2, 0, 6, 0. That also proves that those are zeros. Zeros, x-intercepts. What else did we say? Solutions, roots. Okay, was the other one okay? What? What did I do?
I got 1 and 1 and 2.
Okay, kids, we got this. We got this. Let's do it together. I don't know what. I mean, I don't know. Here we go. 4x squared. I am human, just like you. My blood is red. I believe I make mistakes, correct? Thank you. Minus 12x plus 9. Let's look at this. What did I do? Okay, it bounces. I just had it bouncing in the wrong spot. Let's go to our table. Yep, it looks like it's in between 1 and 2. Now, because of symmetry, what is exactly in between those 2 points? 1.5, right? Does that make sense? 0, 9, which goes off. 1, 1, and then it was 2, 1, and then 3, 9 up here. So we know we can add my 2 points together, divide by 2 to cut them in half, which will put me right here. So 2 plus 1, divide by half, gives me the 1.5. X equals 1.5. There we go. I don't know what happened. These are all touching. These are all touching. If you ever graph it and it's not touching the x-axis, you say no real solutions. But everything that we've done so far, they've touched the x-axis.
It's the only one that has.
It's still touching the x-axis.
Well, the whole number is on.
Right, it wasn't a whole number, but it still touched the x-axis. It's still there. Yeah, it's still touching it. Okay, that's my graphing. Questions about graphing? We're good?
So the solution is just the vertex?
Yes. Well, for this one it is, because the vertex is on the x-axis. Oh, how can you check? Hold on. Stop. Stay with me. How can you check? We can look for the value of 1.5 and make sure it's my 0. Watch. Seconds. Calculate. See the 0? Actually, let's do a value. We're gonna test a value. Okay? To test the value, you can plug in any x and it will tell you the y. So I'm going to test the value of 1.5. And there you go. Y is 0. So that's another way to check yourself. So you can always test an x. You can't test a y, but you can test an x. So that's another cool thing that you can do. Engineering. Yes, sir. Yes. All right, now we're going to review how to solve using square roots. Okay, so let's remember the basics of square roots. What is the square root of 4? And -2, right? We have 2 answers. The square root of 4 is positive and -2. Because what isn't 2 squared 4? And then isn't -2 squared also 4? -2 times -2. So that's why we have a positive and negative, okay? So remember that. You're still going to get 2 answers. Makes sense. We're finding x-intercepts. Typically, parabolas cross over twice. Okay? So notice all of these, the b value is missing. It's not in, well, it's in standard form, but we don't have the piece with just the x. So what we can do is we can isolate our variable. Okay? Our first one, I'm going to add 31 over here, because I can't do square roots until all I have left is the x squared. So now I have 4x squared is equal to 80. Then we're going to divide both sides by 4. And now we have x squared equals 20. So you have to do all of that first before you do square roots. Okay? I have x squared isolated. Now we can square root both sides. Oh no. Square root of 20, you try to type that in, you're going to get a crazy decimal that I don't want. Okay, yeah, I want it in radical form. I know. It's okay. It's okay. Lovelies. Hey, what times what is 20? And make sure one of them is a perfect square. 4 times 5, okay? 1 times 20 does not work. Those are not perfect squares. 2 times 10 does not work. It's not they're not perfect squares. Not to help you simplify. No, it's not, Brennan. Because then that would be the case every single time, right? And it would just be the exact same. You didn't do anything. Okay? 2 times 10 does not work because they're not perfect squares. That's why we're picking 4 times 5. Because when I separate it as the square root of 4 times the square root of 5, well, what is the square root of 4? What? Thank you. Look, we literally just did this. It is positive and -2, right? But is there a square root of 5? No. So positive and -2 times the square root of 5. And that's how you leave your answer. Yes, you leave it just like that. If you want to write them both out, if you want to say 2 square root 5 and -2 square root 5, I mean, you can, but you don't have to. Okay, saying positive and negative shows that it's 2 different answers. All right, moving on to part B. Okay, I have to, before I can make any decision, x squared has to be by itself. So I'm going to subtract 9 first. So we get 3x squared, there we go, is equal to -9. You cannot make judgment yet. The 9 is negative, but you can't make judgment yet because your x is not by itself yet. Okay? Because sometimes that negative will turn into a positive, so watch out. Don't jump to conclusions. For this one, though, when I divide, it does stay negative. -9 divided by 3 is -3. Can we, right now, take the square root of a negative number? No. As of right now, we cannot do that. So we're going to say no real solutions. Because next week, when we get the imaginaries, then we can keep going. But today, we cannot. All right, we cannot do the square root of a negative number today. I actually have a video to answer that question for you next week. Fun fact. All right, my last one with you. There's a fraction and there's parentheses. Oh, no. But you'll be okay. All right, y'all, my turn. How do we move a fraction to the other side? multiplied by the reciprocal, which means you just flip it upside down, okay? We're going to multiply times 5 times 2. Do we understand why this works? No? Okay, side note. If I do 5 times 2 times 2 times 5, that gives me 10 over 10, which is 1, right? That's why we do the reciprocal, because it negates, it's the inverse of what's already there, okay? But what I do to one side, I got to do it to the other side. So those are gone. We still have x plus 3 left over, squared. But now we're equal to 25 over 2, because that's technically 5 over 1. So 5 times 5 is 25. 1 times 2 is 2. Okay? Yes, leave it as a fraction. Yes, because of what's about to happen. I'm going to do blue. All right, so my x is not isolated, but see how it's in parentheses? My parentheses are being squared, so now it's time to square root. Because I can't do anything with that 3 because it's bundled in. So we are going to square root. And if you remember, square rooting fractions, you square root each piece. Okay, hold on. Okay, so I have x plus 3 is equal to, what is the square root of 25? No. What is the square root of 5? Positive and negative 5. Is there a square root of 2? No. Okay. Bringing another Algebra 1 skill back to light. Are we allowed to have square roots in denominators? No, silly rabbit. So, bringing this back for you, we multiply both pieces by the square root of 2. Because it gets rid of the square roots. Because what's square root of 2 times the square root of 2? Square root of 4, which is 2. And our top is still, whoop, there should be a 5 right there. 5 square root 2. This is called rationalizing the denominator, because a square root of 2 is an irrational number, and that can't happen. Lots of Algebra 1 refresh. Hold on, let me finish the problem. Hold on. 5 times the square root of 2 is just 5 square root of 2. Square root of 2 times square root of 2 is just going to be 2. So when you multiply two of the same radicals together, the radical just goes away. Okay? And the plus and minus that we need from square root of 4, it's already there. We have plus and minus in front of my 5. So you don't need to write it multiple times. What's the last thing we have to do to get the x by itself? Minus 3. So when this happens, I'm going to change my color. When we subtract 3, we're going to keep it out front. So x equals negative 3 plus and minus 5 square root 2 divided by 2, like that. So the two x-intercepts is when negative 3 is added to 5 square root 2 over 2, and when negative 3 is subtracted by 5 square root of 2 over 2. You okay? Yeah, you did. Okay. Hold on. Dion, what you got? What's your question? Absolutely not. You just broke the golden rule. A puppy just died. Huh? Absolutely not. Because what does it mean by something being squared? Multiplied to itself, right? That is not x squared plus 9. That would be x squared plus 6x plus 9. Because we just worked with that, didn't we? Going from vertex form to standard form on the test that you did yesterday, where you had to write it out twice in FOIL. Don't do that, Zach.
So why do you have to keep the 3 in front of me?
So because you have the square root of 2, it's an irrational number. Mathematically, you put the rational numbers first, or the constant in front of that. Yep. Any other questions? Yep. You broke that golden rule. Don't do it. All right, it's your turn. If you don't have questions for me, I want you trying these three. You try these three. All right, check your answers. Yeah, when you square root a fraction, you got to watch out. If that denominator is not a perfect square, you're going to have to rationalize the denominator. Okay, so watch out for it. Questions about 1 or 3. What ended up making number 3 no real solutions, by the way? What was it? Negative 5 over 2. So at this point, when you have the square root, that's a negative number. That was the problem.
So, if we just see that the answer is a negative number.
When it comes to the step where you have the square root, and that's a negative number, that's when you stop and say no solution. Yes? No, because if, like, number 2, see how number 2 is equal to a negative? But then I ended up dividing by a negative, and it turned into a positive. So, yeah, don't make the assumption until it's time to take the square root. Good. That was good.